Hello. Hopefully everyone can hear that. Let me know in the chat if you can't. Everybody, welcome to JavaScript with Joe. This is day 7 on the Advent of Code challenges. Last year I tried to do one every single day and it was way too stressful. So my plan this year is do one every Wednesday of every week until they're all done, basically. If you're not familiar with Advent of Code, that's all it is. It's just a daily programming challenge. It normally has 2 parts to it, and the second part will kind of punish you for any shortcuts you take in the first half. I'm trying to do them all in 1 hour, so half an hour for each half. It's worked sometimes. It worked really well the first 3 days, and then it's not been going very well since then. I've linked Advent of Code in the chat, and today we're going to be doing day 7, which again I'll link in the chat, and my solution will be available on REPL here. If there is anyone there, if you're new to JavaScript or you're very good at JavaScript, if you let me know, I'll try and sort of tailor it to people who've never done JavaScript before. I do generally try to explain everything I'm doing, but it's quite hard to actually finish the challenge if I try and explain all of JavaScript in an hour as well. So there's a bunch of videos on this channel where you can watch them all and see how I do various things, and I might be more slow and more descriptive in what I'm doing. But otherwise, let's begin. So day 7, the treachery of whales. A giant whale has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Suddenly, a swarm of crabs, each in its own tiny submarine, is too deep for them otherwise, zooms in to rescue you. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system is just beyond where they're aiming. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. There's one major catch. Crab submarines can only move horizontally. You quickly make a list of the horizontal position of each crab, your puzzle input. So if I look down here, this is our input for the puzzle. Right, so you make a list of the horizontal position of each crab. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions: 16, 1, 2, 0, 4, 2, 7, 1, 2, 14. This means there's a crab with horizontal position 16, a crab with horizontal position 1, and so on. Each change of 1 step in horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them all on, but the one that costs the least fuel is horizontal position 2. Is that just for them? I see what it means. Yeah, okay. So this costs a total of 37 fuel. This is the cheapest possible outcome. More expensive outcomes include aligning at position 1, position 3, or position 10. Determine the horizontal position that the crabs can align to using the least fuel possible, and how much fuel must they spend to align to that position. Okay, so to start with, I mean, my hunch is that we could just try and brute force this. So we could, knowing that we have positions 0 to position 16, we could try all positions 0 through to 16 and just see which one has the lowest fuel requirement. I imagine that'll work very well for the first half of the task, but the second half will probably give us such a huge list that's impossible. I mean, already we've got, I can see in here, around, 1,600, maybe goes up to around 2,000. I can't see anything higher than 2,000 in there. So potentially 2,000 different options, and then we'll have to multiply that by how many things are in this list. I'm guessing there's about, 1,000 there. So already we've got like 2 million different possible combinations, and it's probably going to get more complex after this. I'm going to try the brute force thing. I feel like it's not going to work. It's a bad idea, but we can sort of start with that and see how far we get anyway, or see if that's even good enough. So let's start with this puzzle input anyway. So I've got this little snippet at the top. I've commented it out with Control/ so it won't actually run when I press play. But that will read in from a file like this, so we could start with that. But for now, I'm just going to make my own. So let's do const, crabs equals that. And then, so that's creating a variable called crabs, and it's creating a list or an array, depending on what language you're writing in, just of those numbers. So to start with, let's try and just print out those numbers. And that will show that we can iterate over these crabs. Oh, I'm writing Python already. Last year I did this all in Python, so I normally default to Python. So we could do a for loop, we could map over them. Let's do a for loop for const let I equals 0, I plus plus, and no, it's the condition I is less than. So I want the biggest number in crabs. No, I don't actually, I just want the length of crabs. So less than crabs dot length, and then I plus plus, so that will just say let I be 0, while I is less than crab's length, increment I. Console.log crabs I. What's it complaining about there? Do I need to swap these around? Let me check that. It shouldn't be a comma. Okay, so now it should just log out those numbers for us. So we go 1612, that's what we got here. Now we need to do, again, let's brute force it to start with. So let's make another for loop that will iterate up to this largest number. So we need the largest number in crabs. Up to largest number, and const max, yeah, equals crabs dot, I don't know if there's a max function, we can try it. No. Get largest number in this JavaScript. Do I have access to mathmax? No. Do I have that? Am I using it wrong? I have to spread the array. Okay, cool. So I can use that. Math.max dot crabs. So that's this spread operator in JavaScript. If you've not heard of that, it kind of explodes things out. So if you give it an array, it will sort of turn it into a separated list. I think like this, like actual parameters instead of just being a list. So now I should have my max 16. So I can just iterate up to that number as well. So I can do for, I guess let's do let. Ooh, I'm going to go for X for horizontal. X is less than or equal to max, because we need to go all the way up to 16. And then we're going to increment X, put this whole for loop inside that for loop. And so then we should be able to say console.log for X position X, and I've put a log in here for the crab's eye for crab movement fuel required for crab eye. So that should give us everything we need. So we can double check already that we got, they say position 2 is the correct one. I guess we need a total as well, but let's see. So that's not, okay, yeah, that's just listing it. So next we just need to log out the fuel required, which would be just the what is it? The crab's position minus the horizontal position the absolute value of that, I think. So let's just start with crab's I minus x. And that should just give us the numbers, but they'll be negative sometimes. So we can see here, let's go to the top. So for position 0, crab 0 is at 16, so it's going to require 16 fuel to get all the way over there. So let's store this in a variable. So const fuel required equals crab's I minus x, and then that's probably going to need to be math.abs. So this will make it absolute. So up here, if they were going, I guess it would be shown in the bottom one, if they all have to move to the left, it would be positive. If they all had to move to the right, it would be negative. So that's why I'm adding this absolute. That would just turn minus 15 to plus 15 and so on. So let's use the fuel required there, and we can also create a total. So let's create a total in here. Let total equals 0. And then at the end of this, we can do total plus equals fuel rec. Increment fuel total for this crab. Ooh. And then I want to, outside that for loop, console.log total fuel required is, total won't be, yes it will, okay. So, does that work? Seems to be going quite slow, but I think that's just because REPL is loading. Why is it going so slow? What's happening? There we go. Okay, so we can probably start logging this in here. So we've got our fuel required now. Cool. And we've got the total, so we can see, we should see 41 for the second horizontal position. Ooh. So 37 is what I got, was that right? Oh yeah, okay, so 37. So there's our correct answer if that was our puzzle input. So what we actually need is it to keep track of which one's the lowest fuel so far as well. So let's say let lowest fuel and then we'll set the lowest fuel to be I mean I could just set something really high here and then I can check if things are lower than that, or I could set it to the first total we get. So where I log it here, I should be saying like if total is less than lowest total, let's call that lowest total, then lowest total equals total. And then again, I can log that outside of the loop. Lowest total, and that should give me 37 at the bottom. Do I just need the 37, or do I need how much fuel they must spend to align to that position? Yeah. Cool. So there we go, I get 37. So that would be my answer if this was my input. Sadly, that is not my input. So we can try and paste our puzzle input in there, and we can see again this should log out a huge amount more stuff, and that's a bit messy, so let's move that into the input file as well. Actually, let's start by just seeing if we can read this in. So instead of that, I'm going to say crabs equals this and see if it still runs fine. Input is not defined yet because I didn't comment these out. So these little snippets here should just read in our data for us. Cool, still works. Okay, so I should just be able to paste this in there now. And it should work. It might take a really long time to run because now it's going to iterate up to like thousands of crabs. It's going quite quick, so it might be okay. If I turned off the logging, it would probably do things really quick. Let's see if I can figure out what's happening. I can't tell what position it's on, so maybe let's pause that and save ourselves some of the logging. Fuel required for each crab I'm not too bothered by anymore. Let's just see. Okay, so so it went all the way up to 1931, so I should be able to check if that's in here. Yeah, I'm not sure if there's one higher than that, but it shouldn't have found it. I mean, just without that logging, we did get our answer. So if I scroll back, I should be able to see where that answer came in. No, it was even before 1589. Okay, I guess I could have made this quicker by not using everything as well. I could have just sorted this list and iterated over this list instead. And that will probably speed things up if I need something easier to do next. But for now, the brute force is fine. Let's see if this is the correct answer anyway. There we go, right answer. Awesome. I got 40 more minutes to be stuck on the next bit. Let's have a look. So the crabs don't seem interested in your proposed solution. Perhaps you misunderstand crab engineering. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of one step in horizontal position costs one more unit of fuel than the last. The first step is only 1, the second step costs 2, the third step costs 3, and so on. As each crab moves, moving further becomes more expensive. This changes the best horizontal position to align them all on. In the example above, this becomes 5, which will cost 168 fuel. This is now the cheapest possible outcome. The old alignment costs 206. Okay, so things don't feel like they're going too slowly anyway. So let's change it back to the old puzzle requirement. And then I just need to add something that basically replaces this line here, right? Our fuel requirement is wrong. Our fuel requirement needs to be, I don't know how to describe it. Is it the triangular number of that? Is that what it's called? Triangle numbers? Yeah, okay. I guess this could add like a third dimension to the complexity, right? Where we have to figure out the triangular number, but I'm sure there's just a function we can use to get the triangle numbers. So let's set that back to the input. So it should go back to 31. Now we need to write something here. So this probably makes sense to sort of abstract out something else anyway. So let's do, don't need this anymore. And let's say const calculate fuel requirement. And for this, I need the I guess crab position and the, what was the other one? Crab position and the, I don't know, horizontal position. Let's call it that. Just do an arrow function. Right, so this should, I guess we could test this by saying if it's 0 and 0 to 3, that should give me 1 to move to 1, plus 2 to move to 2, so it should be 3, and plus 3 to move to 3, so it should be 6 total if we try it with that. So let's do console.log, calculate fuel requirement, and let's say 0, 3, expect return 6. And to start with, let's just return 6. Maybe let's do that if I comment all this out, let's just do that. Let's just get that bit working. So we get 6. Now I want to return 1 plus 2 plus 3, which is obviously still 6. Now next I want to figure out how I can get that number from just 0 and 3. So I'm hoping that there's a triangle number calculator in JavaScript, though I could write a little for loop to do it as well. There's a function called triangular. Whoops. Triangular JavaScript. Is there a line? Where did I see that? Is there a triangular function? And somebody's written a nice gist. So I mean, this is what I was looking for. I think this is the triangular function, triangle number function. There should be like a series. The nth term is what I'm looking for. Nth term. Here we go. This is what I'm looking for. Half of n squared. Is that what they've got here? Half of the value times the value plus 1 times the absolute value divided by the value. It looks a little bit complicated, but let's see if it works anyway. No, because that's giving me, that's only looking for one number, but we can still use this. So does that give me 6 as well? Yeah. So as long as I calculate the difference before I pass it into triangular, I think I can just use this. Triangular. And then math.abs crab position minus horizontal position. So they should do the same thing still. So now I should be able to, I should get 10 with 4. And I should also get 10 with 1 and 5, or anything that's 4 numbers apart, basically. Cool. Okay. So I've got everything I need there. This is being hoisted. I think if I function value. Okay. So now I should just be able to use that instead of this. Does that expect absolute? No, it should give me my absolute number back. So I should just be able to do this. And then that should be crab position and x. There we go. So my lowest total is 168. Is that correct? Yes. Okay. That's looking promising. Let's put that back in here. Run that and see if it goes quick. There we go. Done. I mean, I guess we could have calculated the triangular numbers ourselves just by adding them up. And that would have given it some sort of like something cubed complexity, right? Depending on how big the list of... I guess it's only worse when they're really far apart. So even then, we're probably looking at like an extra 1,000 it's multiplied by. But it seems to be, it's quick because we didn't do that actually. We didn't add that complexity. We used the nth term function instead, which I feel like you wouldn't know how to do if you didn't know it's called triangular numbers. So I've helped myself there a bit. And again, we could cut some corners here. Well, we are cutting corners. We could make it simpler. Instead of using this for loop to count over all numbers, we could just count over just these numbers. They don't even need to be in order actually, so we probably should do that. How would I do that? Just iterate over the list instead and set x to be that. But again, it's happened quite quickly, so I'm not too bothered by it. Let's see if we even got the right answer anyway. Awesome! Wow, did them both in under half an hour. That's not happened for a long time. As I say on here, you can see that my last 3 days I haven't even finished, so that's just how it goes. Sometimes they're a lot easier than other times. Is there anything I want to tidy up here? I mean, really, that for loop's the biggest sort of opportunity to improve, I'd say. But otherwise, I've got the answer. I'm pretty happy with it. All I'd really do is like comment out some more console logs, really. Logging the total. Lowest total. Log the answer. Cool. Let's split his inputs up. Again, this was quite cheeky as well, actually. Maybe I'd say to do something better than this, or something to guarantee our largest number. Because that could have been, I guess I would have known if this was coming back as my answer, but that could have been something we were caught on as well. And then this should be to do iterate over known start. It's not actually about start position, so that doesn't actually make sense. That's fine, checking all of them. That's just me assuming that the best alignment point would be where one of the crabs is, but obviously that wouldn't be true if we had, for example, 2 crabs at either end. It would be better if they met in the middle. Cool. Okay, I'm pretty happy with that for now. So again, this is all available in the chat. But yeah, I'll leave it there. I'll stick around if anyone has any questions or anything, but otherwise, thank you very much for watching. Bye-bye.